asymptote condition or long-term behavior or condition. Now, this term is very important, long-term. Long-term means long-term, right? So if the variable is x, long-term means x goes to infinity, long-term. If the variable is x, long-term can be x goes to minus infinity. If the variable is t, long-term can be goes to infinity or maybe minus infinity, right? If the variable is y, long-term can be it goes to infinity, it goes to minus infinity. That's a long-term behavior, right? Now I will show you a few examples so that you will understand how this works. Now you have a parabola here. If you look at the behavior which is happening here, you can see x goes to infinity, y goes to infinity, right? And this side, you can see x goes to minus infinity, y goes to infinity. You can see that. Those are not asymptote conditions. Asymptote condition is like this. Asymptote condition is like this. Suppose you have this. Now you can see here, this is parallel, always this is parallel to the x-axis. This one, y-axis is also parallel, it goes parallel to y-axis. That is called asymptote behavior. So this behavior, how do you catch? When x goes to infinity, you can see x is going to infinity, right? So this curve will never touch the x-axis like that. It will be always parallel. This parallel behavior is happening in the longer term. It is not parallel here, you see? These are not parallel. In the longer term, they are parallel, see? That's why it calls long-term behavior. Now, when x goes to infinity, y value goes to 0. Now we have to understand this one, goes to. It is not y is equal to 0. Y equal to 0 means it should hit y like this. Right? Goes to 0 means it should be parallel like this. Right? So the behavior here, we can say x goes to 0, y goes to infinity. You can see that. You can see this is asymptote condition. This is asymptote condition. And this is asymptote condition as well. Right? So you can summarize in your own word what is asymptote condition. You can observe if this happens when one variable goes to plus or minus infinity, other will go to a constant. Example, x goes to minus infinity, y goes to 0. 0 is a constant. X goes to infinity, y goes to 2. T goes to minus infinity, y goes to 3. Right? So those are examples. Now, I'll give another example here. Think about exponential functions. Think about exponential functions. So I will give you a exponential function here. This is a, and it looks like this, right? So this is y is equal to, I would say, 2x plus a, something like that. So if that happens, this coordinate is going to be a plus 1. We'll discuss that later. Now the important part is to understand this behavior and this behavior. So here you can see x goes to infinity, y goes to infinity. There is not asymptote condition. If you look at this guy, you can see when x goes to minus infinity, when x goes to minus infinity, y goes to a. That's asymptote condition, right? So you can see another asymptote condition in log graphs, right? Log graphs. Suppose you have y is equal to log 10x, most simplest log curve. So that looks like this. So this one is when x goes to infinity, y goes to infinity. That's the behavior which is happening here. The behavior which is happening here is they are parallel to each other. So you can see asymptote condition here. So that asymptote condition is when x goes to 0, y goes to minus infinity. So that would be a asymptote condition. Right? Now, in general, we can discuss about vertical and horizontal asymptotes. Vertical and horizontal asymptotes. Vertical and horizontal asymptotes. Example. Suppose you have a thing like this, right? So I'm considering about this vertical asymptote. Suppose you have a thing like this. Like this. So this is P. Suppose this is Q. Now this one is vertical asymptote. This is a horizontal asymptote. Condition: x goes to P, y goes to infinity. This P value can be a negative value, right? This P value can be a negative value. It doesn't matter. Here, when x goes to infinity, y goes to Q. It's a horizontal asymptote. So that's just a distinction between those two. Otherwise, both of them are asymptotes.